In this session, we prepared a discussion about the thermodynamics and solubility of tadalafil in diethylene glycol monoethyl ether plus water co-solvent mixtures at 298.15 to 333.15 Kelvin. So, tadalafil with a molecular formula of C22H19N3O4 is a white crystalline powder that is usually used for treatment of erectile dysfunction. It is known to be insoluble in water, sparingly soluble in some co-solvents such as propylene glycol and ethanol. Its highest solubility has been reported in PEG 400. The researcher aims to determine the solubility of TDL in monosolvents, particularly distilled water and transcutol, and their co-solvent mixtures by exploiting the commonly used method for solubility measurement in order to make a correlation between experimental data by Appel-Belt model at 298.15 to 333.15 Kelvin. The proponent believed that studying the chemical solubility of TDL could be useful in the pre-formulation studies and formulation development, especially in terms of liquid dosage forms of TDL. So, the main barrier in the formulation development is the poor stability of TDL in water in terms of parenteral or liquid forms. Another common method of enhancing the stability and solubility of drugs in aqueous vehicle is the error-free co-solvent approach. The transcutol as co-solvent has been proven to have the potential of enhancing the solubility of paracetamol in water. Methodology. TDL or tadalafil was from Luna Pharmaceuticals and transcutol was from Gatefoss. Distilled water was from their laboratory, and all chemicals and reagents used were of analytical grade. Measurement of TDL solubility. Shake flask method was used with varying temperature from 298.15 to 333.15 Kelvin at atmospheric pressure of 0.1 megapascals. So after that, the excess amount of TDL was added in known volumes of co-solvent mixtures in triplicate. So it was equilibrated with continuous mixing in an isothermal water shaker bath at 100 rate per minute for 72 hours. So, equilibrium time was optimized by performing the solubility measurement of TDL at various time intervals, 24, 48, 72, 96, and 120 hours. Maximum solubility of TDL was observed at 72 hours. Equilibrium time of 72 hours was selected for the solubility measurements. After that, supernatants were analyzed for TDL content after appropriate dilution with respective co-solvent mixtures. Then, UV spectrophotometry was used in analysis of TDL at 284 nanometer as detection wavelength.
For the data and discussion, this data shows the experimental mole fraction solubility of TDL in various transcutol plus water co-solvent mixtures of mass fraction of transcutol from 0 to 1 at 298.15 Kelvin to 333.15 Kelvin. In all co-solvent mixtures, the data gathered experimentally has a proportional increasing trend between the solubility and temperature. TDL is reported to be the most soluble in pure transcutol given 8.7 and 10.3 at 298.15 Kelvin and is practically insoluble in pure water, giving the lowest solubility of 5.7 times 10 raised to negative 7 at 298.15 Kelvin. These two data are significantly higher than the aqueous solubility at 298.15 Kelvin. The reason why the greater mass of transketol in all co-solvent mixture yields the greater mole fraction solubility is because of the polarity and dielectric constant in co-solvent mixtures compared to water, which is a high polar solvent. Thus, the greater mole fraction solubility of TDL in pure transketol is due to low polarity of the TDL in transketol, and the low mole fraction solubility defines a high polarity of the TDL with water. The results match the recently published solubility data of paracetamol in transketol plus water co-solvent mixtures and indomethacin in PEG 400 plus water co-solvent mixture. So we can say that the experimental data regarding the solubility of TDL in transketol plus water co-solvent mixture is reliable and accepted as true. Here's the data from the testing of the solubility behavior of paracetamol in transketol water mixtures conducted by Fayaz Shikel et al. Using the Appelblatt model, the correlation of the experimental solubility data of TDL with the calculated one, where X is the calculated mole fraction solubility of TDL, T is the absolute temperature, and A, B, C are the adjustable model parameters by multivariate regression analysis of the experimental solubility data. This table shows the Appelblatt parameters A, B, and C, the correlation coefficients R squared, and the root mean squared deviations RMSD for crystalline tadalafil in various transketol plus water co-solvent mixtures. XE is the experimental, XC is the calculated one. And for the RMSD, N is the number of data points in the experiment. This table displays the thermodynamic parameters for dissolution of crystalline tadalafil in various transketol plus water co-solvent mixtures. The delta H was determined by Van Hoff analysis. It is calculated with the help of the mean harmonic temperature, which is equal to 315.25 Kelvin in this study. The researcher plotted 1 over T minus 1 over THM, which is the mean harmonic temperature, versus the lone XE in order to obtain the delta H and delta G, which are both necessary for the computation of the delta S. This graph is the corollary of obtaining the delta H, delta G, and delta S from the equation delta H over R is equal to negative partial derivative of lone X over partial derivative of our x-axis, which is the 1 over T minus 1 over THM. Where R is the universal gas constant or Raoult's law, which is equal to 8.314 joules per mole Kelvin. And the slope is equal to the negative delta H over R. By derivation, we can get the delta H. And the delta G is the product of the Raoult's constant, time, and the y-intercept of the line. After computing for the delta G and delta H, we can cipher out the value of delta S using the third equation. And for references, you may visit the websites and you may go to that link in order to see the PDF file we used for this presentation. Again, I am Justine Cruz.
And I am Ibañez Kristelle Mary A.
of BS Chem 31.